All right, so for the next couple of weeks, we are going to be talking about solutions. So there's a few terms that you need to be familiar with to be able to talk about solutions, all right? First of all, we got to talk about what is a solution. So a solution is what happens when you take one substance and it is dissolved in another. So I just love this part of in the English language, and really any language, right, where you're going to use the word like solution, and you use another word like dissolved, right? Like, what is the act of making a solution? What's the act of dissolving? Well, what's the act of dissolving? Well, the act of making a solution becomes a circular thing. Can't really define things that way. So what does it mean for something to be dissolved in something else? All right. What that is a process that we call solvation. Okay. Sounds a lot like salvation, not related at all to that word. Solvation is the process whereby you take, let's say you have a beaker of water, okay? And we're going to draw a beautiful, this is a gorgeous beaker of water. And we're going to put a lump of something inside that beaker of water. Doesn't matter what that something is. Could be salt, could be sugar, could be poison, whatever your imagination wants to go to. That last one's a little dark. I'm just saying. But anyways, inside this beaker, right, there are molecules, okay? And those molecules, what they're going to do is they're going to surround and they're going to stick to this thing that we put in there. So these things right here, you know what, let's make them blue. You know what, let's change the color here. Hey, digital learning, right? So the blue things here, they're supposed to be kind of like carrots, okay? So the blue things are water molecules. And what they are going to do is they are going to surround that thing that we put in there, that substance that we put in there, and they are going to slowly start to pull it apart. So we're going to draw kind of a four-dimensional, in time drawing here of what's going on inside this beaker. And so what's going to happen is we're going to have that substance. I'm going to try in here and make it about the same size, but at least a tiny chunks are starting to come off of it. All right. And what's happening to these tiny chunks is those water molecules are then going to surround those tiny chunks, right? And they are going to drag those tiny chunks, those tiny particles, off into solution. Now, if they're big enough, right, then once you get up into the rest of the water, they can keep to pull them apart. And eventually what we're going to wind up with is over, a long period of time, is you're going to look inside of here and you're not going to see anything, right? You're not going to see anything. All that's going to be inside here is going to look like just a regular beaker of water. Maybe there's some color change to it. Maybe it got a little bit thicker, right? So the viscosity might change, but it's not going to look like anything. And that's because if we go and we zoom in on any part of this beaker, right? Doesn't matter which part of the beaker you look at, but at any part of the beaker inside of here, what we'll see is we'll see water molecules, and they are attached to a tiny chunk, all right? And so we're going to make a little dot here, and that little dot is going to be the smallest increment of our original substance. All right, so that could be an atom. It could be an ion. Or it could be a molecule, depending on what thing we put inside here, right? An atom would be an element. So if you can get an element to dissolve in water, then what you'll look inside there is you'll see a little atom and it's surrounded by water molecules. Doesn't often happen. All right, we'll talk about that later. If it was an ionic compound, right, the water's going to break apart the ionic compound. You're going to look inside there and you're going to see the ions surrounded by water molecules. If it's a molecule like sugar, for example, right, you put sugar in there, then each sugar molecule is going to eventually get pulled apart and they're going to get surrounded by water molecules. So this is the process of making a solution. It's called solvation, all right? And it is the process by which the molecules of one thing surround the substance, right? The particles of the substance you put in there. All right, we're getting to a point where I need to define two other things here, okay? And the two things that we need to describe here, I'm going to use what's up above here, this black substance that we put in there. We call that thing the solute, okay? The solute is the thing that's being dissolved. So it's the thing that gets broken apart and dispersed through the solution. The solvent is doing, there we go, the dissolving. So we have the solute you put into the solvent, and the solute is what's going to get picked apart. All right? So knowing those two words are really critical for us to talk about solutions. All right? What we're going to do is we're going to talk about, as chemists, we have at least three major ways to talk about the strength of a solution. And the thing that we measure when we measure the strength of a solution is called concentration. So one last word here, one last definition. The concentration is the strength of the solution. And I always think, when I think of concentration, I always think of sweet tea. As a good Southerner, I like my sweet tea super duper sweet. I like mine with a high concentration. My wife was raised in New England. She does not like her tea sweet. She likes it, quite frankly, she likes it to taste like grass water. That's what I say, right? She's like, oh, just dip the tea bag in there. That's all you need. No. You gotta put some sugar in there. But she likes hers with a low concentration of sugar, right? I like mine with a high concentration of sugar. She likes hers with a low concentration of sugar. That's just how we talk about the strength of the solution. Now, we're going to measure concentration in three different ways, all right? We're going to tackle each one in one day. Today, for the rest of the day, we're going to talk about molarity, because I think it's the easiest one. And then tomorrow we'll talk about molality and all the things that means. And then we'll talk about percent next week.